Today we're going to learn how to backtest stock trading strategies in Python using a package called Zipline, which allows for event-driven backtesting, which means we're simulating the days one by one, or we're backtesting the days one by one. So we're going through the history. This happened on day one, this happened on day two, and day by day we make decisions. We can implement our own strategies with different technical indicators, with technical analysis strategies. And then we can see how we would have performed if we were to apply the strategy in a specific time frame. So in this video today, we're going to learn how to implement these strategies. We're going to work with different data sources. We're going to take a look at things like leverage and shorting, and also considering the transaction cost, also trading multiple assets. So we're going to learn a lot today. If you like this video, let me know by hitting a like button and subscribing. And now let us get right into it. Alright, so we're going to learn how to backtest our stock trading strategies using a Python package called Zipline. And I'm going to tell you about the history of this package a little bit because you need this for context. But first of all, very important here, every time I do financial videos, this is not financial advice. This is not a finance tutorial in any way. This is a programming tutorial. I'm showing you how to use a package, what strategies you use, and what you interpret, how you interpret the statistics. I might make mistakes here when it comes to explaining financial concepts. You are responsible for your own decisions. So this is not a financial tutorial. It is a tutorial, a programming tutorial on a financial package. But of course, you need to know what you're doing, and I'm not responsible for any losses or whatever you do with your finances here. So having said that, let's briefly talk about Zipline. Zipline was a package by Quantopian, which is a company in the quant space, I guess, and they're no longer maintaining this package. So this package is basically dead, but there is a guy here, Stefan Janssen, if that's the correct pronunciation. He also writes books, so maybe you want to check them out. But he's basically keeping a bunch of these finance packages alive. Pyfolio, Zipline as well, and he's keeping this package alive. He's maintaining it. So we have Zipline reloaded, which is the thing that we're using in this video today, and this is the documentation page. So Zipline is for event-driven backtesting. The idea is we have assets that we're trading. We have a certain strategy. This can be every time certain metrics cross, every time certain metrics go above a threshold, we're just going to go and buy or sell stocks. And how we define that strategy is what we're going to learn in this video today, and we're going to also see how to evaluate them. So let us move into the setup. I'm going to go into my tutorial directory. This is where I want to be working in. This, of course, works on all different operating systems. I'm working on Linux here. You can do the same thing on Mac. You can do the same thing on Windows. The installation is just a Python package. So either you use your core Python installation by saying pip or pip3 install Zipline, and then reload it, of course, if you want to have the current one. Or in my case, I'm going to use the UV package manager. So if you also want to do that, you need to make sure you have UV installed. You can do that also using pip. And once you have UV, you can say UV init, but you don't have to use UV. If you don't know what UV is and it confuses you, just don't do it. Use pip directly, install Zipline reloaded. In my case, I'm going to say UV add Zipline dash reloaded, and that is going to give me the package. Later, we're also going to install other packages, but I want to start with a very simple strategy. I want to implement a completely random stock trading strategy, which is basically every day we're going to flip a coin, and if the coin is, in this case, it's not a coin, it's a threshold. So if the random number between 0 and 1 is above 0.5, we're going to buy stock, otherwise we're going to sell stock. And that is exactly what we're going to do here. Nothing too fancy, just to show you how we can build the most stupid strategy there is. So for this, I'm not sure if Pandas is installed, but we're going to use Pandas as well. It's part of Zipline already. And I'm also going to activate my virtual environment here to get auto completion in my editor. Now I'm using NeoVim here. You can use VS Code, you can use Jupyter Notebooks, whatever you're comfortable with. You just open a file with that editor, delete everything, start a blank new file. I'm going to call mine main py here, but I'm going to rename it later. And we're going to start by importing pandas as PD. And we're also going to import from Zipline .api the function order target. Now you have multiple different ways to order stuff, to place an order. You can go for target, which means that you're targeting a certain number of shares, like order target 100 of a certain ticker would be I'm aiming to have 100 shares of Apple, for example. It doesn't mean that I order 100 shares. It means that if I have 50, I'm going to order 50. If I have 0, I'm going to order 100. If I have 100, I'm going to keep 100. And if I have 200, I'm going to sell 100. So the target is always like where I want to end up. We're going to use that order target method or function here. And we're also going to use record to keep track of stuff, and also symbol for the ticker symbol. Now, in addition to that, we're also going to say from Zipline itself, we import the run algorithm. There's two ways in which you can run Zipline scripts. You can run them in the file or you can run them with a command. I'm going to show you both, but we're going to go with the code way of running the algorithm. It's just nicer in my opinion. And then also we want to import random because our strategy is just going to be flipping a coin. So the first thing we need to define is a function called initialize. So we're going to say initialize, and this function is going to take in context and it's going to do some stuff. Now, what it does depends on what we want it to do. But in my case here, I want to start at a specific day. I want to say that in my context here, I is initialized as 0. Day 0 is the first day of trading. And I can also define the ticker symbol. So context.ticker is going to be equal to symbol and then Apple. Or actually, ticker is not correct because ticker is Apple. Since we're going with symbol Apple, I should say it's the asset that we're trading. Context asset is symbol Apple. So this is now our context that we initialized. The second thing is going to be handling the different days. So we're going to say handle data, and this is going to take in context and data. So we use the context we have, and we also have data that we want to process. And here, basically, we have our trading logic. So one thing that we're going to do here is we're going to advance I. We're going to always go to the next day. So I is going to be plus equal to 1. And then my basic trading strategy will just be if random.random, this is a number between 0 and 1. If that is above 0.5, so that's basically a 50% chance, then I'm going to buy. So I'm going to say order target. I'm going to provide the asset, which is context.asset, and the target, which is 100 shares. And otherwise, I'm going to just do the opposite, which is I'm going to target 0. So we're always either going to own 100 shares of Apple or 0. So we don't have anything else. We're just buying and selling 100 shares of Apple stock. Now, important for the actual back testing, we need to record stuff. We need to keep track of stuff. So I'm going to say here record, and we can provide keyword arguments here to keep track of stuff. Now, in this case, we don't have any fancy indicators, so I'm just going to keep track of the price. So I'm going to say AAPL is equal to data.current. And then in here, we need to provide the asset, so context.asset, and as a string, the thing we're interested in, the current price. So we're keeping track of the Apple price and we're buying and selling. And a lot of stuff is also being kept track of automatically, like the portfolio value and everything. We don't need to calculate this manually, but now we're recording the price of the Apple stock. Now, theoretically, we can already close this and use a command, which I'm going to have to copy or not copy, but type from my second screen because I don't know it off the top of my head. But basically, we can run this strategy now by saying Zipline run. And for this, you need to be in your virtual environment if you're using UV so that it recognizes Zipline, or you have to do UV run, but Zipline run is fine. And then we say -f and the file that has the strategy, so main py. And then we say --start, and we provide a starting date. And let's go here with 2014, 1st of January. And then we're going to also say end date is 2018, 1st of January. Then we also provide an output. -o is going to be results.pickle, for example, and then --no benchmark to compare against. Now, this will not work the first time you do it. I'm not even sure if it's going to work in my case now, but what you need to do for this to work, and in this case it does work because I already did that, you need to have data on your system. You need to actually have data that you can work with, and the default data source here is Quandl. Now, Quandl might not be optimal for a number of different reasons, so I'm also later in the video going to show you how you can use the Y-Finance package to download current data for free without an API key. I want to show you both though, because that's the simple way to do it. That's the default way to do it with Quandl. So Quandl, I'm not really too familiar with it, but basically it's a NASDAQ thing, a NASDAQ API, I think you could say. So you just have to log in, you have to sign up. You don't have to pay anything for that. You just go to NASDAQ data link, and then you go to your account settings and you will see an API key. In my case now, hopefully I'm censoring this out, but that is an API key that you need. Now with this API key, it's totally free, but you can only access data from the past. So you're downloading a wiki, I think it's called, data set, and you're not really allowed to access data that is current for free. You can pay and get the up-to-date data. So we're going to work with the past data for now, and later in the video, I'm going to show you how to use the Y-Finance API to just download any data you want and then do the same thing here. So for that, what you now need to do is you need to say export and then Quandl_API_key. and then is equal to whatever API key you got from the account settings. So I'm not going to do this here. I already did this, but you just have to export this in your command line so it exists as an environment variable. And then you need to run the zipline command, zipline ingest-b, and then quandl. So quandl is going to be downloading this specific bundle is what they call it. So you're downloading the quandl data. So yeah, once this is done, you can just run the strategy and it's going to use the data from this time frame, in this case for Apple, and you get a results object, so results.pickle. Now I'm going to show you how to run the same thing also in Python first, and then we're going to take a look at the results. So instead of doing this in a command line, you still need to do the ingest command, but instead of running the strategies in a command line, you can also say here, if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, then we're going to run the algorithm. And here now we need to provide a bunch of arguments. So the first thing is we want to have a pd.timestamp. So that's going to be our date for the starting date. Here we're just going to say 2014-0101. I'm going to copy this. I'm going to say end is equal to the same with 2018. The initialize function is going to be equal to initialize. The handle data function is going to be equal to handle data. Then also interesting, capital base, we can also provide it in the command line. We can set this to a certain value. So I start with $10,000, for example. However, this is not necessarily enforced. I mean, it is kind of enforced, but you do have the problem that if you don't provide specific extra stuff that we're going to talk about here in a second, that you can basically buy whatever you want with leverage. So we can provide this, but it's not going to be super important because even with $1, I can buy endless amounts of Apple stock just because I can use leverage here. Then we're going to say data underscore frequency is daily. So we have daily data. And then important here, bundle is equal to quandl. And later on, as I said, we're going to change this. Then we can use our yfinance CSV files. But for now, we're going to use quandl. It's just the simplest way to do that. And now I can do uv run main py, and we get the same thing. So I can actually remove the results to show you that they're going to come again here. So uv run main py, and we're going to get the results.pickle file. And this thing here returns actually the results. So we're going to say results is equal to run algorithm. And we need to export them to pickle. So we need to actually say here results.to_pickle, and we're going to call this results.pickle. There you go. So we can save this, and now I can just do uv run main py, and that is going to result in the same thing as before. We don't get all the output, but you do get the results pickle. So I can also remove that here, results pickle, and run the whole thing again, and then it will be there afterwards again, results pickle. So now to take a look at the results, we're going to actually use JupyterLab. Now this is optional. You can use a Jupyter Notebook. You can use an ordinary Python script. I just want to use JupyterLab. So I'm going to say here uv add, which is again the same as pip install on your system. Uv add is going to be JupyterLab, the first package, and the second package matplotlib for visualization stuff. And once we have this, I'm just going to go and say Jupyter space lab, white space lab, and this is going to open this in my browser. So I actually get an interactive Python notebook to take a look at all the stuff. So I can open a new notebook here. I can call this analysis.ipynb, and in here now I can load the pickle file. So here now I can say import pandas as pd, and I can load this thing as or from a pickle file. So I can say pd.read and then pickle, and then results.pickle, and I can say that this is equal to df, and then I can say df, and I get a data frame here. I can zoom out with a bunch of different columns. Now, one thing that you will notice is that a lot of columns are hidden, and also that some values are difficult to read. I mean, right now we don't see that, I think, but oftentimes you will have difficult values that are difficult to read. So we can set some pandas options here to make things easier for us. I'm going to say pd.options.display.max columns is going to be equal to 500. And for the other one, we're just going to wait until it becomes a problem. But basically, I get here now a bunch of columns, a lot of columns. The interesting ones probably for us right now is we want to know how much money we made. So we can see that the starting value of the portfolio value in the beginning here is 10,000. That's our capital that we started with. And then at the very end, it's 19,000. So it seems like we made some profit. But again, take this with a grain of salt because we have leverage. I can just buy stock and then I have more money because the stock went up, even though I started with less money than I would have had to buy stocks. But you get a bunch of columns here that are interesting. We're going to take a look at them later. What I want to do now is I want to just look at the portfolio value over time. So I'm going to say df portfolio underscore value dot plot. And this is going to give me the visualization of the portfolio value. We start here at 10,000 and it goes up and then kind of steady, stays around the 20K mark, I would say. But yeah, this is the random trading strategy. We're just doing something. Every day is a coin flip, whether we're going to sell or buy. But now let us take a look at how we can actually do something useful. So how could I actually implement something that might have some brain in it? So I'm going to move my terminal to a different workspace. I'm going to also move the notebook and I'm going to open up another terminal, go to my tutorial directory, activate my environment again, and then we're going to open up a second file. Let's call this one SMA Strategy.py. And actually I want to copy most of what we had in main py, but we're not going to use random anymore. We're going to use a simple SMA Crossover Strategy, or I think it's called maybe dual SMA strategy. The idea is we have one SMA, simple moving average for 30 days and one for 100 days, for example. And when they cross, we want to make a decision. So since we're going for 100, let's go and first of all say skip the first 100 days. So we're going to say if context.I is less than 100, we're going to say return. Because in this case, we don't want to do anything. We just need to let some days pass so we can calculate the simple moving average of the past 100 days. So then we're going to say SMA 30, simple moving average for the last 30 days, is going to be data.history. We will provide the context.asset. We will provide the attribute price. And then we say bar count 30 for the last 30 days. And frequency is going to be equal to 1 day. And then we can copy this. We can say the same is for 100 days, and that's going to be bar count 100. So now we have these two metrics, and basically when they cross, we want to make a decision, want to buy or sell. So if the 30-day simple moving average crosses the 100-day simple moving average, then I want to make the decision that we're going to buy stocks. And otherwise, if the 30-day simple moving average goes below the 100-day simple moving average, we're going to sell. We're going to target 0. That is as simple as it gets. And we can also keep track of these values now. So I can say SMA 30 is equal to SMA 30 and SMA 100 is equal to SMA 100. And of course, don't forget the underscore here because otherwise we're going to get some errors again. And also very important, we need of course to say .mean to get the mean from this time frame, not just the data itself. Otherwise we don't have the average of the last 30 or 100 days. So now let's go and run SMA strategy. This will produce a new results file. And for this, we can go back to workspace 4. And here we can just rerun the code and see what happened in this case. And now we can see the final portfolio value is also 19,000. So not too different from the random strategy. Doesn't mean anything, of course, but that is a simple one that we can do. Now, one thing I mentioned is that this is not a reliable thing because I can just buy stocks even if I start with very, very little capital. If I go here and I change the script to be starting with a capital base of $10, I'm still going to be able to do all the trades. So I can run this and it will not tell me, hey, you can't do the trade. You cannot buy 100 shares of Apple because you don't have money. I can just go and use leverage. So what I want to do to actually make this more realistic, to actually make this more, to actually see if this actually works, is to set the option to only be able to go long, so we're not shorting, and to also not use leverage. So I'm going to import that from the Zipline API, set long only, and set max leverage. And we're going to just call this in initialize. I'm going to say set long only, and then set max leverage is going to be 1, so 1.0. One more thing, if we don't want to get the exceptions, because if I do it like this now, we probably will get an error when trading. So we're going to get a signal and it will tell us that this violates the constraint for leverage. So in this case, what I want to do is I want to check if this is possible. Can I even do the buy? If not, I'm not going to do the buy. I'm just going to skip. So what we're doing here is if we want to buy, we're going to say if the context.portfolio.cash is greater than or equal to 100 times the price of this, of one share, basically, of this asset. That's going to be data current context.asset price. We're assuming no transaction cost here and no slippage or anything like that. If that's the case, then we're going to buy. Otherwise, we're not going to buy. So that's super simple. And maybe we should not start with 10. That's a little bit, that's not enough. But let's go with 10,000 again. And let's see if this still works without problems. So it produced the file. Let's go to space number 4 here. And I'm going to rerun the entire code. And you can see that in this case, actually, we lost quite a bit of money. Or we actually didn't lose money, but we are basically back to the beginning. So this strategy didn't work out too well for us. Maybe the random one would have worked better. We can actually give this a try as well. I can just use my old strategy again. Instead of saying this, I'm going to say if random.random is greater than 0.5, then we're going to do the buy logic. And then I'm going to say else we're going to do this. We can still keep track of the moving averages. That's not going to harm our performance. So let's run this and see if this works. Okay, I do get the violation. This is probably an issue with the timing. So maybe we should say if we have a little bit more than that, let's just go with a safety buffer of, I don't know, $10 or something. And now this should work, because otherwise, you know, you have maybe enough money, but then there's some small issues and you don't have enough money anymore. But let's go and see if this now performed well. It performed better, at least. It doesn't look super nice, but this would be the portfolio value over time. But these are all like play strategies. Let's try something else. Let's go and use a MACD, like a moving average convergence divergence, I think was the name. So let's call this MACD strategy, PY. Of course, again, we're going to copy most of the stuff that we have here, and we're just going to change the small bits. But one thing that is going to be interesting here is we're going to involve another package, which I also made a video about, TALIP, Technical Analysis Lib. So we're going to actually use this to calculate the MACD using TALIP. So for that, we're going to go back out. We're going to say pip install or uv add and then ta-lib. So that is going to add the Technical Analysis Lib, and we can now use it easily, or use that to easily calculate the MACD. So I can say now the context, let me go full screen again. The context here, if we have the first 50 days, so if that is less than 50, we're just going to return. And otherwise, let's get rid of all this. We're going to get the prices of the last 50 days. So prices is going to be equal to data, history, context, asset, price, then what was it, bin count, bar count, I think, 50, and then frequency was 1D. And these are the prices now. We're going to use those for the MACD. So we're going to say MACD signal and histogram is equal to TALIP. And of course, we need to import that actually. So let's go here, import TALIP, go back down, and we're going to say this is equal to TALIP.MACD. And here we need to provide some data now. So prices, and then the default settings are fast period 12. Then slow period is 26. And then the final thing is the signal period is equal to 9. So this gives us now the MACD, the signal, and the histogram. We only want the last value. So MACD is going to be equal to MACD -1, like this. And then we're going to do the same thing for signal, and for the histogram value. So hist is equal to hist -1. And our rule is basically going to be if the MACD goes above the signal, we're going to buy. But of course, we're going to check again if this is possible. And otherwise, if the MACD is less than the signal, we're going to go to 0. And we're going to not keep track of the SMA because we don't have it, but we're going to keep track of MACD. signal is equal to signal and hist is equal to hist. So that would be another very basic strategy, UV run macd strategy. And now if we go back to our notebook, run everything from top to bottom again, we can see that this one actually performs quite well. So over this time period, we would have ended up at around 14K with this strategy, considering that we're using no leverage. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. Now, I want to go back to the SMA strategy and show you how we can do shorting, so how we can actually short stocks. And for this, we can keep everything as is here. But instead of just going to 0, if the SMA 30 is less than the SMA 100, we're just going to short the stock. And we do that by saying negative 100, which means we're selling 100 shares that we don't own. And for that, of course, we're going to get rid of this, and we're going to also get rid of that. So I'm going to comment this out. And this now is basically also a shorting strategy. So I can say UV run SMA strategy, and this is going to sell stocks or bet against stocks as well, instead of just not buying them or selling them. So let's run this and see if this was a good decision in this specific time frame. Yeah, I mean, we did have quite a dip here. So the max drawdown is quite crazy, but we do end up at a very high position, but this is with leverage. So take that again with a grain of salt. So now I want to show you probably one of the most important things. How can we actually download data that is not Quandl data, because Quandl requires an API key, is paid. So here now we're going to create a script called download yfinance.data.py, or call this whatever you want. I'm going to save this file, but also, of course, we need to install the yfinance package. So either again pip install, or pip3 install, or uv add and then yfinance. This is going to add the yfinance package here as a dependency. And now we can just download the data set using this script that we're going to write. And we're going to then turn this into a CSV file and then register it as a proper bundle with Zipline. So to speed this up a little bit, I'm going to do copy pasting here. I'm not going to copy paste the entire thing at once because I do want to explain what we're doing, but I want to save time here with typing. So I'm going to just copy paste segments. If you don't know how to work with yfinance, I have a crash course on this channel where you can see how to work with the yfinance package, but it's actually quite simple. We start by importing pandas and yfinance. We define a couple of ticker symbols that we're interested in downloading. These are going to be in our data set, so we can then access the stock prices of these ticker symbols. Then we iterate over these ticker symbols. We basically say data frame is equal to taking the ticker instance of that ticker symbol, get the history from 2014 January to 2026 January. So this is up to date. We can actually use the current data that we have, or actually this is like a couple of months ago, but you can still also adjust this to be today essentially. And then what we do is we reset the index. We rename the columns to be compatible with the Zipline notation. So date is date, open, but all in lowercase. We then also fill up the other values that are part of Zipline. So we have the date here. We turn this into a specific format, into year, month, date with dashes. We have dividend 0, split 1, and then we just get all the columns. The data frame is now limited to these columns, and they're also in the right order, the columns. And then finally, we say here, for column in all the columns, df column is equal to pd to numeric. So we're typecasting that, we're dropping all the nan values, and then we're exporting this to a directory here, which is Zipline CSVs. You can call this whatever you want. /daily. This is important. You need a notation, some directory /daily, and then ticker CSV. This is important. You need to do it like this, and you need to make sure that this directory exists. So I'm going to say make directory here, and I'm going to create Zipline CSVs /daily. So that's going to create a directory, and then I can just run the download yfinance data script. So now if I take a look, we do have the data in Ziplines and daily. There are the CSV files for the respective companies. And now what we also need to do is, this is a global thing. So this is not limited to a project. You need to go to your user directory on Linux and Mac. You go to user and then .zipline, and then there's an extension .py file. And in here, I already have this because I played around with this for the video, but I'm gonna have to change stuff because now we're actually working with a different directory here. But basically, you just import pandas, you just have the Zipline stuff. By the way, all this code will be on my GitHub, so you can copy paste it from there if you don't want to type it. But basically, we just define the time frame here, and we use register from Zipline to register whatever you want to call this. I call this yfinance CSV directory bundle, and we pass your daily and the path. So home neural 9 documents programming neural 9. Here it should not be YouTube preparation now, and not Zipline tutorial and not Scratch, but we're gonna go with tutorial/Zipline. So that's just gonna be the directory that I'm working in. And then we have calendar name, New York Stock Exchange, start session, end session. That's essentially it. What we need to do now, once this is set up, is we need to run the ingest command again. So we need to run zipline ingest -b, same as Quantal before, but with yfinance CSV dir bundle. So that is going to load this as an actual data frame here, or as an actual data source here. And now we can just go into our MACD strategy, for example, and change the bundle to be equal to our yfinance CSV dir bundle. And this allows us, of course, to also use timeframes that are more modern. So I can go with 2025, or actually let's go with 2025. That's fine. And so I can now save this, and I can do UV run MACD strategy again. And this will now use my data source with the yfinance data that I downloaded as CSV. And if I now go back here, I can run the analysis, and you will see that we have the time frame being up until 2025, and we're going up here with this strategy. Now, by the way, also I copy pasted this now. We have other columns that are also interesting here. So we can go, now I don't have results. I actually called this df. So let's say that results is equal to df, because this is my prepared code. Basically, we have stuff like final portfolio value, total return. This would be 160 to 63-ish% return. So basically we more than doubled our portfolio value. Max drawdown basically means the worst dip we had from a peak down to the valley is negative, or it's 17.75% drop. Sharp ratio of almost 1 is not that good, but I would say okay. So starting with 1, it's getting into the good section of the Sharp ratio, the good range. Total orders is how many trades we made, total transactions here. And then we have also the last position. So what does our portfolio look like in the end? Because it could also be empty because we just sold and didn't buy again. So this is some interesting stuff to look at, but you can also just go and say df columns to see all the different columns. And probably some of you guys watching this will be finance experts, so you don't need me to explain to you what all this stuff is and what you can use it for. I'm showing you how to work with it on a programming basis. Now, I want to show you how to work with multiple ticker symbols. So let's go back to our MACD strategy, and let's say we're not just trading Apple, we are trading multiple tickers. I'm going to be trading Apple, I'm going to be trading NVIDIA. So I'm going to say tickers is Apple, is NVIDIA. Or actually, let's make this more intelligent. We're going to say here that the assets we're trading are going to be a list. So it's going to be .assets, and that's going to be a list. And we have symbol Apple here. And we have, not this, there you go, symbol Apple here. And then it's going to be symbol NVIDIA, and it's going to be symbol Meta, or what did I have actually in my download finance data? Yeah, so Apple, Meta, NVIDIA, Tesla, and Google. So let's go with that, Tesla and Google. And then we just have to make sure that we iterate over them and trade all of them. Now, we're also going to set a target weight. So I'm going to say context.target weight is going to be 19%. So we're trying to have 19% of each of these stocks in the portfolio, if possible. And then here now I'm going to start a loop for asset in context.assets. I'm going to say if not data can trade asset. So if you cannot trade the asset, we're just going to continue. And otherwise, we're going to do all of this here. So basically, all of this stays the same, but we're going to record more data now. We're going to record a dictionary that we're going to unpack. So I'm going to say record. And then here, I'm going to say asterisk, asterisk. So unpacking operator here with dictionary. And we're going to use formatted strings. So asset.symbol. And then underscore price is going to be equal to the price, or in our case, that's the data current context, or actually not context, it's just asset and then price. And this is of course important because here we also shouldn't have context.asset, but just asset. That's that. And then we're gonna copy this here and do the same thing with MACD and with signal and with hist. And then we're gonna say that that's actually just the MACD and the signal and the hist. So that's that. Let's see if this works or if I forgot something. So let's run the strategy. Trading algorithm has no asset. Yeah, this is a problem, of course. So at some point I didn't actually replace this. So that is the context asset here. Of course, that's just the asset, not the context asset. And it seems like we have another one. So that should be context assets. There you go. Order target is of course asset and not context asset, because now we're iterating, so it's not in the context. And also, of course, one very important thing that we didn't do, I of course didn't replace the order target in general. We need to also say we're now going to order the target weight. So that's going to be order target percent. So order target percent is the function here. And we're going to say order target percent asset and the context dot target weight. And here it's just going to be target percent 0. So order target percent asset 0. And of course, you should spell context correctly. So UV run MACD strategy. So now it has to execute, of course, 5 times the same logic. So this will take a little bit longer. But also we can do a very interesting visualization because of that. I'm going to copy paste this one too, because of course, this is not a Matplotlib tutorial and we're already spending too much time on writing all the code here. So this is now done. Let's go into the analysis notebook here. This is going to be still the entire portfolio value. So that's going to be like this. This is crazy, probably mostly due to NVIDIA is my guess. And we can see what the last positions look like. So speaking of that, I'm going to now show you here. I have it in my notebook prepared because I already did, of course, all the coding. Here we have a simple Matplotlib script. So we have last positions and the cash amount that we still have. This is what we didn't spend on stocks. And now if I just run this, we will see a visualization here of our portfolio in the end, 62% cash. So that's almost 50K. And NVIDIA and Apple are still 18.8% here. That's awesome. And that's a very nice visualization to have here and to analyze the portfolio performance. But again, we started here, I think similarly with a portfolio value or starting cash of 10K. And in the end, we have way more than that. So this is the cash, where's the portfolio value? There's the portfolio value. You start with 10K and now you have 80K in the end. This is very nice. Now, the very last thing I want to show you here is how we can actually also consider or take into account the transaction cost. So for this, we can say from zipline.finance import the commission and the slippage. So this is basically commission, what you have to pay to the broker, and slippage for the timing delays and everything. And we also need the 2 functions here, set commission and set slippage. So we're going to say here set commission, and then we can say commission is dot per share. So per share, we have a certain cost. Let's say the cost is 0.001 and the minimum trade cost is nothing. And then I can say set slippage as well. And I can say it's a fixed slippage with a spread of 0.01. So we can just set this up to have a more realistic scenario here. Now, probably let me remove some of the tickers so we don't have to run through all of the stuff again. I'm just going to go with 2 of them, with the 2 winners, Apple and NVIDIA. I'm going to run this. And now we have also the transaction cost and everything. So this is also kept, or this is also taken into account. So now again, back to the notebook, and let's see. We're not going to really probably see a huge difference here. Yeah, still going up to the moon, so to say. Yeah, so this is backtesting with the Zipline package in Python. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help from a freelancer, if you need some help with a project, if you need consultation. You can contact me at the bottom of these pages using LinkedIn or email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.